Let's do in this video one more example with starting from symbols and not words. So here we have a binomial problem, probability of getting an x between 60 and 80, but without 60 and 80. N of 200, so that's large, so that's good. P of 0.35, so we think about the normal approximation. Alright, so again, you would pause this to try it yourself and then check my answer. Okay, so first we check for the normal approximation. So we do the n large thing in our head. 200 is greater than 50, so that's good. The other part, the mean, it's likely to be good, but we'll just run through it officially just to see this. Oops, jumping the gun on the answer here. I believe the answer to that will be 70, which is greater than 5, so that's good. Alright, so the normal approximation is good. And so we can go ahead with this problem. First thing we do is to translate this to a binomial where we have equal signs. So this is between 61 inclusive and through 79, where in 200 p of 0.35. Alright, since in the original statement 60 was not included and 80 was not included. Okay, what next? Well, we're going to go to the normal distribution, but let's just to circumvent slowing us down here, let's get the standard deviation first. So there's the square root of NPQ, that's 200 times 0.35 times 0.65. 200 times the p of 35 times the 1 minus p of 0.65, that's 6.745. Just to check myself that I wrote it down correctly. Alright, so this can be written as approximately equal to, and we go down a half from the lower limit, we go up a half from the upper limit. Mean is 70. Standard deviation of the normal that we're going to use to approximate 6.745. Okay, so now we have a normal distribution problem, and we would just do the same as the last video with our normal distributions. Mean 70, going from 60.5, which is below that, to 79.5, which is above. We have an area that straddles the mean, so we're going to add these two probabilities together. Alright, so on the z distribution, we're going to calculate those z values and then look the values up in the tables and add them together. So z values, x minus mu on sigma, x, the lower limit first, 60.5 minus 70 is approximately 10 divided by 6.745. It'll be a number just greater than 1, right? But negative 1. So 60.5 minus the mean of 70 divided by standard deviation minus 1.41. For the lower limit on the z, and then I'll skip the formula. The upper limit will be the x of 79.5 minus the mean mu of 70 divided by the standard deviation. Alright, so 79.5 . minus the mean 70 divided by the standard deviation tops A1 cell, and the least limits are symmetrical again. That's positive 1.41. Alright, so our Z distribution probability statement, whatever you want to call this, goes from negative 1.41 to positive 1.41. Again, a symmetrical area, both the same size. All we'd have to do is find one and double it. And so to 1.41 will be 0.4207. Doubling that will be what, 0.8414. Okay, and that's that problem. Now look at a word problem. Okay, but the routine is the same. We have to translate the words first into a binomial problem. We'll then check for the null approximation and then just go ahead and do it. Okay. Alright, a student is about to take a 60-question multiple choice exam. 4 answers are given for each question. Okay, only one of the 4 is correct for each problem, of course. What is the probability that a student will guess at least 36 correct by guessing? Alright, so what is the probability? At least 36 means 36 or more out of 60 questions, and the probability of getting any one question correct, well, he's got a 1 in 4 chance. Since there are 4 answers given, just choosing at random, there's a quarter probability, 0.25. Okay, so check for the normal approximation. Alright, it is large, so that's the first thing we think of. Well, actually, in general, we can think of either of 2 things. Either think of the Poisson approximation or the normal. Poisson approximation, the p would be tiny, or p would be large, so its complement would be tiny. But in this case, p of 0.25 is not what you would consider tiny. N is 60 is greater than 50. 2, the mean NP 60 times a quarter is 15. It's greater than a half, so the normal approximation is good. Alright, before we go to the null approximation, let's do 2 things. Let's write this binomial with 2 limits with equal signs on our inequalities. Right, lower limit is 36, and we're going all the way up to, and as high as we can go, is 60 out of 60 correct. It's of course not going to happen, but it conceivably could. Okay, so that's the proper or explicit binomial with both limits. Before we go to the normal approximation, let's calculate the standard deviation. Square root of np times complement 1 minus p. Square root of 60 times 0.25 times 0.75. The square root of 60 times 0.25 times 0.75. 3.354. Alright, so this is approximately equal to the normal probability statement. From the lower limit we go down a half, 35.5. The upper limit we go up a half to 60.5. The mean is, what was the mean? Alright, 15. Standard deviation 3.354. diagram. Mean of 15, and we're going from 35.5 through 60.5. We're going to translate this to the z distribution. Find the z values corresponding to these two limits. Okay, so z is x minus mu on sigma, x 35.5 minus the mean mu of 15 divided by the standard deviation 3.354. So 35.5 minus 15. Alright, was that about 20-ish divided by the standard deviation of about 3, so we got 6.11. Okay, so the lower limit is way out there, so that upper limit is going to be a long way out, right? 60.5 minus 15 divided by 3.354. So nearly useless figuring that out. Okay. Anyway, that's 60.5 minus what was the mean? 15 divided by the standard deviation. And that's going to be, as I said, a lot further out. 13.57. Okay, so doing it properly, get the large area first from 0 to 13.57, that's approximately a half. Then we subtract out this, which from 0 to 6.11, and this is also approximately a half. Alright, so just writing it down so that you can see the elements. If you don't understand the answer yet, so this is approximately a half minus approximately a half, so the area probability is approximately 0. Okay, probability of getting 36 out of 60 correct, yeah, get a D, it's not going to happen. Okay, so don't think about it on your regular exam. And now let's do one more. You should try this one yourself and then watch my answer.